Hello, my name is Weil. I'm a professor at the University of Maryland in the Department of Environmental Science and Technology, and I'd like to give a brief presentation covering a decade of research really by my lab on cover crop management to reduce nitrogen leaching loss from cropland. With a little background, in Maryland, most grain farmers are quite progressive. They've been using no-tillage methods for decades, and they've been using cover crops for more than a decade. The high amount of cover crop use shown here compared to other states in the US is largely due to the fact that the state of Maryland has a cover crop subsidy program that generously pays the cost of putting in cover crops with the objective of preventing nitrogen from leaching to the Chesapeake Bay, which is suffering badly from eutrophication. Early in our work, we noticed that cover crops indeed can take up large amounts of nitrogen, but rarely could we find as much nitrogen disappearing from the soil as we saw being accumulated in the cover crop biomass. This could be partly due to continued mineralization of nitrogen from organic matter, but we thought perhaps we weren't looking deep enough. Perhaps the cover crops were actually taking up nitrogen from layers deeper than we were sampling, even though we were sampling to 1 meter. So we did a survey of about 45 commercial farm fields in the region, including neighboring states. And we did transects of cores down to 2.1 meters deep at the end of the season when nutrient uptake had ceased by the crop. And we found that at the end of the season, there was 250 to 300 kilograms of nitrogen per hectare on average left over in the profile in mineral forms, about half nitrate and half ammonia. And about half of this mineral nitrogen was sitting in the profile deeper than 1 meter. And surely nitrogen that's soluble, that's already a meter deep, is very, very susceptible to leaching. So the first question was, could cover crops actually go that deep? And we did some studies with N15 tracers and buried them at 1 meter and 2 meter deep and found that indeed cover crops like rye and radish that have very rapid deep rooting systems were able to capture the tracer nitrogen from this depth before the onset of winter, leading us to a new model of how cover crops reduce nitrogen loss by cleaning up the deep nitrogen in the soil in fall before the winter leaching system, which is in contrast to the typical view of cover crops being active all winter long and removing nitrogen from the leaching water. We believe the action is in fall before winter, cleaning up the soil so that when the water does percolate through the soil during the winter, it doesn't find soluble nitrogen to carry away. In a series of experiments on different planting dates and types of cover crops, we found that the accumulation of nitrogen in the above ground biomass of the cover crop was the best predictor of how much reduction there would be in the nitrate leaching during the winter. And they also noticed that weeds, even when they took up as much nitrogen as the cover crops, were not nearly as effective as the cover crops, probably because they had more shallow root systems and couldn't get that deep nitrogen. So the question then became, how do we establish cover crops early enough to get roots down deep and clean up the profile? One way of doing this is with airplane application of the seed before the main crop, the cash crop, is harvested. So this is an airplane spreading cover crop seed over a maize field. And the maize field is probably 3 or 4 weeks from harvest. And the other picture shows the result after the maize is harvested, quite a nice cover crop stand of forage radish. We collaborated with commercial farms in the main farming region of Maryland for a number of years. Anywhere from 7 to 9 fields were enrolled. Each of these fields were planted to cover crops by airplane on half of the field. These are large 10, 20 hectare fields. And the other half of the field was harvested and then drilled with ground no-till equipment. In the second 2 years, we also had a no cover strip down the middle. What you can see here is that in the 2 dry years, when the cover crop, when there was very little moisture to germinate the broadcast seed from the airplane, and when it was very easy to get in and harvest on time and drill, the extended season airplane flown system in the red performed about as well as the standard system did in terms of reducing nitrogen leaching compared to the control here. In the wet year, when it was difficult to harvest the crop on time, when the soils were wet and muddy and difficult to drill, and the seed germinated quickly, the flown system, the extended system, greatly outperformed the standard system and greatly reduced the amount of nitrogen lost. So in light of this kind of data, the Maryland subsidy program added an additional subsidy to reward farmers who planted before September 15th, an extra $25 per hectare. So while this made it a bit more expensive for the state, the results are that show that it was money well spent. We looked at this from the farmer point of view, from the amount of money the farmer spent on the cover crop. With the extended system, per dollar spent, the farmer was able to keep 0.33 kilograms of nitrogen on the farm compared to only 0.2 kilograms on the standard system. From the point of view of the society and taxpayer money spent in the subsidies prevented the leaching loss of 0.28 kilograms of nitrogen per dollar spent compared to 0.18 for the standard system. So we believe that encouraging early planting of cover crops, even with extra subsidies to do so, is money well spent. My email is at the bottom, and I'm happy to take questions anytime you can do that.